Hello students, I am Manoj Kundare, the Assistant Professor of Electronic Science. Welcome back to our e-learning platform. In previous video, we have seen the block diagram of the operational amplifier. The link of the previous video is available in the description box. Please check it. Now, in this video, we are going to see the parameters or the characteristics of the operational amplifier. Before going to see the parameters or the characteristics of the operational amplifier, let's see the equivalent circuit of an ideal operational amplifier. This is the equivalent circuit of the ideal operational amplifier. In the circuit, we can see there is the inverting input terminal V1 and non-inverting input terminal V2. Similarly, there is the output terminal plus VCC and minus VCC. If we see this diagram, then we can see here there is the Z in, that means the input resistance between the inverting and non-inverting input. Similarly, at the output there is the Z out. Here the Z in is called as the input impedance and Z out is called as the output impedance. Okay, let's see the parameters one by one. First one is the input impedance Z in. The input impedance is the ratio of input voltage to the input current and is assumed to be infinite to prevent any current flowing from the source supply into the amplifier's input circuitry, that is IN is equal to 0. That means the input impedance is the ratio of input voltage to the input current. Input impedance is also called as the input resistance. It is assumed that the value of input impedance should be infinite, because if this value is infinite, then it prevents any current flowing from the source supply into the amplifier input circuitry. For ideal op amp, the input impedance is infinite. Practical op amps have input leakage currents from few picoamperes to few milliamperes. For practical op amp or the for IC741, the input impedance is 2 mega ohm. That means the input impedance Z in should be infinite. Okay, and for 741, this value is about 2 mega ohm. Now let's see the next parameter, the output impedance Z out. This is the output impedance Z out. The output impedance of the ideal operational amplifier is assumed to be 0, acting as a perfect internal voltage source with no internal resistance so that it can supply as much current as necessary to load. That is, the value of output resistance or the output impedance Zin should be 0, because to supply more value of current to the load which is connected at the Vout pin. Okay, that means to supply more current to the load, the value of Z out should be 0. This internal resistance is effectively in series with the load, thereby reducing the output voltage available to the load. This Z out is connected in series with the load. Okay, I hope you all understand this. For ideal op amp, the output impedance is 0. But for practical op amp or for IC741, the output impedance is 75 ohm, or it is between 100 to 20 kilo ohm. I hope you all understand the output impedance Z out. Let's see once again the output impedance. The value of output impedance should be 0, because if this value is 0, then the op-amp can provide much current to the load. For that purpose, it is always connected in series with the load. Okay. Now let's see the next parameter, the bandwidth. The bandwidth of an amplifier is the range of frequencies over which the input signal are amplified are almost equally. That means simply we can say that the bandwidth is the range of the operational amplifier over which it can amplify the signal. The bandwidth of op amp should be as large as possible. For ideal op amp, the bandwidth is infinite. But for practical op amps, the bandwidth is limited by the gain bandwidth product, which is equal to the frequency where the amplifier's gain becomes unity. For practical op amp or for the IC741, the bandwidth is 1 megahertz. That means the bandwidth of the amplifier is the range of frequencies over which it can amplify all the frequencies in it, and the bandwidth should be as large as possible, but practically it is not possible. Ideally, the value of the bandwidth is infinite, and for IC741 its value is near about 1 megahertz. This is the graph of the gain versus bandwidth. Okay. Now let's see the next parameter, differential gain. We know that the operational amplifier is the differential amplifier. That means it amplifies the difference between the input. For the op amp there are two inputs, inverting input and non-inverting input. Hence the differential amplifier amplifies the difference between inverting and non-inverting input. Now let's see more details. It is the gain of the amplifier when differential input is supplied, that is input V1 is not equal to V2. The output equation of differential amplifier is V0 equal to AD V1 minus V2. We know that gain, the value of gain is equal to V out upon V in, but V in is available in V1 minus V2. Hence we get the equation V0 is equal to AD into V1 minus V2. But V1 minus V2 is equal to AD. Hence we get V0 is equal to AD into VD, where V0 is output voltage, AD is the differential gain, and VD is the differential input. I hope you all understand the differential gain. The final equation or the expression for the differential gain is AD is equal to V0 upon VD. I hope you all understand the differential gain of the operational amplifier. Now let's see the common mode gain or AC of the operational amplifier. It is the gain of the amplifier when both the inputs supplied are equal, that is V1 equal to or nearly equal to V2. That means when we combine both the input, then we get the common mode gain. Theoretically, since V1 minus V2 is equal to 0 because both the values are same and one terminal is negative while other is positive, hence we get V1 minus V2 is equal to 0. Therefore the common mode gain is also 0, but ideally it does not exist, so common mode gain is extremely small and tends to 0. I hope you all understand the differential mode gain and common mode gain. Let's see once again. The differential mode gain is the gain when V1 is not equal to V2. Okay, then we get the gain is known as differential mode gain. But when V1 is equal to V2, then we get the common mode gain, and in common mode gain the gain should be 0. Okay, I hope you all understand what is differential mode gain and common mode gain. Let's see the next term, CMRR. The CMRR, that means common mode rejection ratio, is the ability of the differential amplifier to reject the common mode signal successfully. That is, the common mode rejection ratio is the ability of differential amplifier to reject the common mode signal successfully. It is called the figure of merit of the differential amplifier. CMRR, or the common mode rejection ratio, is also defined as the ratio of differential gain versus the common mode gain. That is, CMRR rho is equal to AD upon AC, where AD is the differential gain and AC is the common mode gain. The value of CMRR is tends to infinity because AC has the value 0. Due to AC equal to 0, the value of CMRR is always infinity ideally. The CMRR also expressed in decibel. For that purpose, the formula is CMRR is decibel is equal to 20 into log 10 AD upon AC. Okay, I hope you all understand what is the common mode rejection ratio. It is very simple. The ratio of differential gain versus the common mode gain is known as CMRR, and ideally its value is infinity, but its practical value is 90 decibel. I hope you all understand this term, common mode rejection ratio. Now let's see the next term, slew rate. The slew rate is defined as the maximum rate of output voltage change per unit time. It is denoted by the letter S. That means the slew rate is the maximum rate of output voltage change per unit time. The slew rate should be as high as possible to ensure the maximum undistorted output voltage swing. Slew rate changes with the change in the voltage gain. Therefore, it is generally specified at unity gain condition, that means unity plus 1 gain condition. Okay. The equation for the slew rate is given by S is equal to dV0 by dt, where it is has the maximum value and its unit is volts per microsecond. The ideal value of slew rate is infinity, but practically the slew rate is 0.5 volt per microsecond. That is, the slew rate is the maximum rate of output voltage change per unit time. That means at a given time, the output voltage changes or not, this condition is defined by the slew rate. It is denoted by letter S. Okay, and it is specified in unity gain condition. Its equation is S is equal to dV0 by dt, where dV0 is the output voltage and d by dt is the rate of time, change of rate of time. I hope you all understand the term slew rate. Now let's see next term, the PSRR. The PSRR, or the power supply rejection ratio, is the ratio of the change in the offset voltage to the corresponding change in the power supply voltage, provided all the remaining power supply voltages are constant. That is, PSRR is the ratio of delta in upon delta V supply. Ideal value of PSRR is 0, but practical value is 150 microvolt per volt. Okay, now let's see all the parameters in short. The first one is, or first characteristic is input resistance. That means the input resistance is the resistance between the V1 inverting and non-inverting terminal. This resistance is known as the input resistance or input impedance. Its value should be infinity, but for IC741 its value is 2 mega ohm. The next term is output resistance. This output resistance should be connected in series with the load, okay, to give maximum current to the load. For that purpose, it is connected always in series with the load. Hence, ideally, the value of output resistance or the output impedance should be 0, and practically it has the value 75 ohm. Note here that the input resistance is input impedance and the output resistance is the output impedance. Now let's see the voltage gain AB. The voltage gain of the amplifier, the ideal value is infinity, and the value for IC741 is 2 into 10 raised to 5. We know that the voltage gain AV is equal to the output voltage upon input voltage upon the output voltage. Okay, now let's see the next, the bandwidth. The bandwidth is the range of frequencies over which the amplifier can amplify its signal. Its ideal value should be infinity, and for IC741 its value is 1 megahertz. The next is CMRR, that means common mode rejection ratio. Its ideal value is infinity, and practical value for IC741 is 90 decibel. Next one is slew rate. The ideal value of slew rate is infinity, and for IC741 it is 0.5 volt per microsecond. The next is input offset voltage VIOS. Its ideal value is 0, and for IC741 it is 2 millivolt. Next one is PSRR, that means power supply rejection ratio. Its ideal value is 0, and for IC741 its value is 150 microvolt per volt. The next is input bias current IB. Ideal value is 0, and practical value for IC741 is 50 nanoampere. And the last one is input offset current IOS. Its ideal value is 0, and practical value for IC741 is 6 nanoampere. I hope you all understand the parameters or the characteristic of the operational amplifier. Now let's see some common features of the IC741, that means 741 operational amplifier IC. It has no frequency compensation required. The IC741 has the short circuit protection. In IC741, the offset voltage is null. In IC741, the large common mode and differential voltage ranges are available. Also, in IC741, there is no latch-up. These are the features of the IC741. I hope you all understand all the parameters or characteristics associated with the operational amplifier and its ideal and practical values of IC741. Thank you.